Hello. We're in the next section now. We just talked about solving equations and things like that. Now we're going to look at, basically the rest of this chapter is going to be talking about applications of solving equations. So I know you probably know that means word problems, but we'll get to that. These problems in this section are fairly straightforward, so I think we'll be okay. And then we will get to word problems in a later video. And we'll have a procedure for how to go about them. So don't worry. If you have a phobia of word problems, I think you'll feel better after we really go over it and kind of take our time. So anyway, this section's about applications with percents. And you've probably seen these problems before in a previous math class. So notice here in example 1, we're going to tackle that one first. All it's asking is what percent of 76 is 19? So the thing is, there are a lot of ways to go about these. I know you probably learned different methods as you were taking your previous math classes. And there are some of you that you're just really good at these problems. You just read it and you know exactly what to do. I know, oh, I need to multiply those two things, or I need to divide these two things. So if you're in that boat where either you just know what to do or you have a different method that you like to use, that's fine. You don't have to use the method that I'm going to go over in this section. It's just optional. I'll go over it, and if you like it, you can stick with it. I think it's pretty good. It's not too complicated. But again, don't feel like you have to use this method. You can do these in any other way and maybe check to see if we get the same answer, that kind of thing. But let's see. So, okay, let's go. Just jump right into it. So at the top of the page, we see it says to solve percent problems. Like I said, yeah, you may use any method of your choosing, but I'm going to use the following reasoning, which isn't too complicated. So all it does is it kind of translates words into an equation. So here you have kind of the key words that mean different things. Kind of like we saw with the I guess in the review chapter, we were looking at different kind of word problems. If you see the word is, that's code word for equals, things like that. But these are kind of special for percent problems. So let's see, the first one here it says the word of is keyword for multiplication. So as you're reading kind of the sentence, as you're reading it from left to right, as soon as you see the word of, I would write a multiplication sign and then go on and write other things down as you go. So that's a key word that it's not obvious what that would mean. And then maybe we'll move off to the right here. The next word is actually what we've seen before in the review video. If you see the word is, that's code word for equals. So that one's not anything new. We've already seen that. So the only new one you have to memorize so far, if you want to use this method, is that the word of translates into multiplication. And then down here on the kind of bottom left corner, the word what translates to a variable x. And you can use whatever, you don't have to use x, you can use any letter you want. But that one I think is pretty obvious in a way, because if they say, what percent of blah, or if they say, 10% of what is, it's all, in these problems and word problems, it's always the thing you're looking for is what you're going to let equal the variable, right? So as soon as you see the word of, oh, that's the thing I'm trying to figure out. So I'm going to let the variable equal that thing. So I think this one is not much of a code word. I think we already knew that one. And then the last one, this is another thing that you've probably seen before, but it's kind of hard to remember. If you're given a percent in a problem like this, so notice in example 1, we don't see a percent. That's the thing we're going to have to find. But if we're doing example 2, for example, you see 30%. When I translate everything into an equation, I'm not going to use 30, the number 30. I'm going to, like it says, change it to the decimal form of that percent. And if it's been a while since you've done that, I kind of have it just to outline how to change a percent to a decimal form. If you want to change a percent to a decimal form, maybe we'll kind of come up with an example here. Let's say, 42%. So if you have 42%, and you want to change that to a decimal, or, change it to its decimal form, all you do is think about, okay, right now, 42%, 42, I don't see a decimal, but whenever something is a whole number, there's an invisible decimal directly to its right. So you can think of 42, it's the same as 42 point nothing. So you're going to imagine the decimals there. Now you're going to move it like it says in the directions twice to the left. So this way it becomes 0.42 or 0.42. It's kind of up to you whether you like the 0 in the front or not. Either one's good, but that's basically how you change a percent to a decimal. You just find out where its decimal is, move it twice to the left, and that'll be the number we're dealing with as we solve these equations. All right, I think we're doing pretty good, and the more you practice these, the better you'll get at translating. So all right, let's get started. Example 1. So what I would do is read these from left to right, and as you read 1 or 2 words, I'd start writing down what they stand for, the code words. So in example 1, right off the bat, they say what. And like it says above, the word what you can think of as a variable. What percent? So the word percent, I don't think we really need to write the percent symbol because I guess we'll just keep in mind that the answer should be a percent. So in the end, I just got to make sure I have a percent. So X will stand for the percent that we're looking for. What percent of? Okay, the word of, that was code word for multiplication, right? So I'm going to put a little multiplication symbol. If you don't put the symbol, you put 2 things next to each other. We all understand that means multiplication. So you don't really need to put that symbol if you don't want. But okay, the word of is multiply, all right. And then directly after the word of, I see a number. So I'll just write it. Now, so notice as we go, we're just writing everything down from left to right. The word what? That's X. The word of? That's multiply. The number 76, that's already a mathematical thing, so I'm going to leave it as it is. And the next thing I see is the word is. And from the review video that we did, we know that is code word for equals. And then the last thing in that sentence or in that question is 19. So that must be it. 76 times X or X times 76 equals 19. That's what we're trying to solve. And I think it looks kind of strange because we're used to seeing a variable on the right side. If 2 things are multiplied, one a number, one a variable, I think I'm going to rewrite it as 76 times X instead of X times 76. That kind of freaks me out. I don't like it. And then it just comes, that was the hardest part, is translating it. And then solving is pretty okay because we've taken a couple sections previously to solve these guys. The only thing is you're not going to get pretty numbers usually. That's the sad part. So let me see, if I solve this for X, I'd have to divide by 76. All right. So it looks like X is going to be whatever 19 divided by 76 is. Well, maybe I'll go off to the side and figure that out. 76 into 19, here we go. No one likes this. And I realize, of course, 76 can't go into 19, so I have to add a decimal and a 0, and then place a decimal above it and start dividing. 76 cannot go into 19, but it can go into 190. I'm guessing twice, because 2 times 70 is 140, but 3 times 70 is 210, which is too high. So I'm imagining it's a 2. Let me see how that goes. 2 times 76, what would that be? 152, I believe. Is that true? Yeah, I think so. All right, and then we'll subtract those guys. Let's see, that would be 38. Gotcha. Okay. And then let's see. Usually, I think they design these so that the numbers work out pretty well. Because if you remember, some of these times where you're dividing decimals, this could go on forever. But I think they try to make it so it'll stop eventually. Maybe you find 2 or 3 digits and you'll be done. I'm going to bring down one more 0, and I have a feeling that we're probably getting close. Let's see, 76 into 380. I'm not too familiar, with the multiples of 76, so I'm going to start guessing. Well, we did 76 times 2. 76 times 3 would be something like 210 or higher. I think I need something more than that. How about 76 times 4? Well, 70 times 5 is 350. That might be pretty close. I'm going to see maybe up here. What is 76 times 5? Maybe that's exactly what I need or close to what I need. Let's see, okay, so 6 times 5, that's 30. 7 times 5 is 35 plus 3, 38. Ooh, that's perfect. That's exactly what we want. We'll put a 5 there, multiply the 5. We know it's exactly what we want. Yay! So X must be 0.25, but you got to be careful because just like how we said, if you're given a percent, you want to translate it into a decimal. If you find something, if your answer is a percent, if you solve an equation where your answer is a percent, you're going to have to change that back into percent form. So we're going to have to go backwards from what we talked about earlier. We said Well, if you're given a percent, you move the decimal to the left twice to make it a decimal. But if you're given a decimal like we have, we're going to move it twice to the right to change it back to a percent. So if I move that decimal twice to the right, that's 25 decimal. But since there's nothing beyond the decimal, we don't really need to write it. We're good. 25%. All right. And I think you can a lot of times you can see does that sound about right? Let me think about the earlier numbers. They said 19 out of 76. Do you think 19 out of 76 sounds about like 25%? Well, I always think 25%, that's a quarter. So do you think a quarter of 76 is 19? Sure. That sounds about right. I mean, it's close. If it seems like way wrong, then I think you can tell right away. All right, I think we did a good job. All right, I might as well try the next one. I'm having a good time. I hope you guys are too. Let's see. So example 2. And again, I'm going to try to translate it word for word as they say it. So from the very left, the first thing they say is 14. I'm just going to write that down, 14. And then the next word is, what did we say that was code word for? Oh yeah, equals. That's right. And in this one they actually give me a percent instead of me having to find it. So I want to write that, but like we discussed, you have to move the decimal to the left twice. So it becomes 0.30. Because 30% has a decimal to the right of the 0. If you move it twice, it goes directly in front of the 3. All right, so we got the 30%. The word of, what did that mean again? Oh yeah, multiply. Gotcha. And then what number? Oh yeah, the thing you don't know, the number you're looking for is going to be x. Or if you see the word what, you know you're going to use a variable. All right, this one looks pretty good, huh? I mean, and like we discussed before, I don't know if I would put that multiplication symbol every time. You can probably just put 0.30 and x next to each other, and that's good enough. All right, now we're ready to solve. So again, yeah, setting it up is usually the hard part, and then solving it's usually easy. It's just a little tedious when you're having to divide or multiply not pretty decimals. All right, so since I want to solve for x, I'm going to have to get rid of this 0.30. And since 0.30 is being multiplied by x, I'm going to divide by it to get rid of it. And again, I do not enjoy dividing decimals, but here we go. So I'll have x by itself. It'll be whatever 0.30 is divided into 14. Let me see. And 0.30, that's the same as 0.3. A 0 at the very right side of your decimal number doesn't really do anything. So I'll just to simplify it, I'm going to write it as 0.3. And then you don't probably very often divide decimals by hand. You probably use a calculator or use the calculator on your phone or something. But I think we might have discussed this before in a previous section that if you want to divide decimals, you can move the decimal to the right as many times as you want, as long as you do the same for the other number. So I'm kind of thinking I'd rather not divide 0.3 into 14. I'd rather just divide 3 into 14. I wish that decimal was gone. So I can move it to the right once, so that it's a whole number 3, as long as I take the decimal on 14 and move it to the right once. So it'll make the number I'm dividing into larger, but it'll make the number I'm dividing by prettier. The number I'm dividing by is now 3, and 14 now changes to 140, now that I've moved the decimal over. All right, that looks a lot better. I'm much more excited about dividing 3 into 140. All right, 3 cannot go into 1, but it can go into 14 4 times, because 4 times 3 is 12. And if I subtract 14, subtract 12 is 2. Let me bring down that 0, and I think we're getting close to the end, hopefully, huh? 3 goes into 26 times. 6 times 3 is 18. If I subtract those guys, I get a 2. All right, since I'm not getting a 0 remainder, I guess I gotta add a decimal after the 140. Put a 0 there. I better do the same thing for my quotient here. So my answer is going to be 46 point something. I'll have to find out what that something is by bringing down the 0. And again, this shouldn't last too long. Usually they try to make these, only last a couple decimals. So now it's a 20. 3 divided into 20 is another 6, huh? I think I can see what's going on here. We're going to keep getting 2's as our remainders. So I think our answer, what you can say is x is 46.6. If you remember, if a decimal goes on forever, you put a little line above it. I don't know if that sounds familiar, but that's the exact answer. I guess it depends. If in some cases you'd want to round it, say oh, that rounds up to 47%, you know? But if you want to be exact, if they ask for an exact answer, then it's 46.6 with a bar above the 6. Because that shows someone that's reading this that the decimal goes on forever. So, anyway, kind of depends how they want your answer, but I think they want exact answers in this section. Okay, we're doing good. Having a good time? Well, it's sort of not too bad except for the kind of tedious division part. I'd have to admit that. All right, let's try example 3. What does this one say? Yeah, again, I'm going to just read from left to right. It starts off right away with 0.3. I'm going to write that down. That was code word for equals. And then again, they're giving me a percent here, 12%. I'm going to write that in decimal form, 0.12. And remember we discussed earlier, if you don't like to put 0.12, you just like to put 0.12, that's fine. You don't really need the 0. I kind of need it so I don't forget there's a decimal there. I know that's kind of sad, but what can you do? So 0.3 is 12%. The word of means multiply. What number is your variable? So I know in the last 2 examples I've actually put a little multiplication symbol, but I think I'm used to it by now, so I'm just going to write x next to 0.12 so I just kind of remember what's going on between them. I think that's what we want to solve. Not too bad, not too bad. Let's go for it. All right. These kind of all look the same, huh? Now I need to get x by itself, and since x is being multiplied by 0.12, I'm going to divide both sides by it here. Oh, and another tedious division. Wonderful. I love dividing, don't you? Oh well. X is whatever 0.12 divided into 0.3 is. But don't worry, when you're dividing decimals, you don't have to put up with that crap. Oh, sorry, is that a bad word? Oh well, don't tell anybody. I'm going to move the decimal to the right twice, because I'd rather divide by 12 than 0.12. But if I do that, I got to move the guy inside the division bar's decimal twice as well. See, so the guy outside, he just becomes a 12, which is what I wanted. But the guy inside, though, if I move his decimal once, it'll become a 3. But moving its decimal twice makes it a 30. And that's not going to be pretty. I wish 12 went into 30 an even number of times, but at least it's better than 0.12 into 0.3. Ugh. All right, might as well get started here dividing. We got, let's see, 12 can go into 30 at most twice. 2 times 12 is 24. If I subtract those guys, I get 6. And dang, not a zero remainder. So I have to do like we did in the last one and put a decimal, add a 0. I'm not going to forget to put a decimal in my answer as well. And bring down this 0 here. Now ask myself, 12 times what is 60? Huh? I think it's exactly 5. Is it? It is! Yay! 5 times 12 is 60. I feel like I lucked out on that one. All right, so I guess x must be the quotient 2.5. See if that sounds right. What'd they ask? 0.3 is 12% of what number? So does it sound like 0.3 is 12% of 2.5? Sure, why not? That sounds about right. All right. If you care enough to think that hard. All right. Next one. Next example sounds kind of interesting. So it starts off, it says, what number? Okay, I know that's going to be x. Gotcha. The word is, that means equals. Okay, I like that. Now 1%, gotta remember that 1%, if I change it to a decimal like we're supposed to, it's not going to become 0.1, it's going to become 0.01. Because moving the decimal once to the left would move it right in front of the 1, but moving it twice would move it in front of the 1 and again, which would make you, or cause you to put a 0 there. So let's be careful on that. You don't want to just put a 0.1. A 0.1 would be the decimal form of 10%. So be careful. So what else do we have here? 1% of, okay, multiplied by 1 million. Ooh, that's pretty serious. 1 million. Holy shamoles, you guys. Well, actually, I think this type of percent problem is my favorite because you actually don't have to solve the equation. You notice right away, x already was by itself on one side of the equation. So our job is only to figure out what is 0.01 multiplied by 1 million. That doesn't sound too fun, but hey, at least I don't really have to solve. And I don't have to divide. I'd much rather multiply than divide. So it seems silly, but I'm going to set this up kind of like the really long multiplication. I got 1 million multiplied by 0.01. Okay. This is kind of strange, but if you remember, just, this 0.01 is a decimal, but let's just imagine it's a 1 and multiply it. I know it seems silly, but I'm going to multiply 1 times the first 0, that's 0. 1 times the second 0, another 0. The third 0, another 0. The fourth 0, another 0. The fifth 0, another 0. The sixth 0, another 0. Finally, we're to the 1. There he is. And then at this point, to know where you put the decimal, all you do is say, okay, how many places were beyond the decimal here? There are 2 digits beyond the decimal. So that means I need to take the decimal that I have, which, the way it was written, it looks like a whole number. So I'm going to put the decimal directly to the right and move it twice to the left. So I should also have 2 digits beyond the decimal in my answer. That means, what would my answer be? I have 1, 2, 3, 4 zeros and then a 1. That's 10,000, huh? 10,000. Does that sound right? Does 10,000 sound like it's 1% of a million? Sure, why not? That sounds about right. Oh, hello, sorry. Okay, so those are fun. I think it's more tedious than difficult. Setting it up, now that we kind of know the code words, they're not too bad, right? I think they're pretty good, they're just tedious. I don't enjoy the division or the multiplication so much. Okay, so these last problems in this section, they're going to actually have context. Like this one is, what is it talking about? Someone leaving a tip on a meal, and you want to know what percent that was and all that. So what you might want to do is, since we kind of mastered the previous examples where they just said things like, what percent of blah is blah, or 10% of blah is what I think the best thing to do is try to rephrase the problem you're given in these ones as a problem like the previous ones. So let's see, in example 5 it says, Trent left a $4 tip for a meal that cost $25. And the first thing they want to know is, what percent of the cost of the meal was the tip? So let me try to rephrase it. So it kind of sounds like one of those problems above. What does it kind of sound like? It sounds like they're asking what percent of, okay, they said the cost of the meal, but they said the cost of the meal was $25. What percent of the cost of the meal was the tip? And they said the tip was $4. So that makes it sound a lot like those problems above. That's kind of the key here. And then once you rephrase it like that, you can solve it just like we talked about in the problems above. So I'm going to try to translate that into an equation. What percent? Okay, what percent? That's x. And again, the percent part, just keep in mind x will be a percent in the end. The word of means multiply by something. The word after of is, or the number after of is 25. That must be what I'm multiplying. And if you look at the word was, you think, wait, that doesn't look like one of those keywords. But keep in mind, was is past tense for is, right? So just think was and is, they mean the same thing. It's just is now and was is past, but still, same thing. Was means is, and is equals, and then 4. There it is, 25x equals 4. Now I just have to solve that. And of course I would solve it by trying to isolate x. I'm going to try to divide by 25 here. And then I'll have x by itself. X must be whatever 25 into 4 is. Oh, great. Another division. We love this stuff. No, we don't. What are you talking about? Okay. I can't divide 25 into 4. So I better add a decimal and a 0. And then do the same thing. Add a decimal right above it. All right, 25 into 40. It can only go in once, huh? Because twice would be too much. 1 times 25 is 25. If I subtract those guys, I get 15. Is that true? Yeah, sounds good. All right, I'm not getting a 0 remainder, so I better bring down another 0. I think this will be the end because I know 25 goes into 150 evenly. It goes in 6 times. 6 times 25 is 150. So there we go. All right, so that must mean x is 0.16. But remember we said if you're trying to find a decimal by solving these equations, you're always going to end up with the decimal, you're always going to end up with the decimal form of the percent. But if you want the percent, you're going to have to move the decimal back to the right twice. So you mean that's the correct answer if you say 0.16, but they want the percent form, not the decimal form. It's really 16%. Does that sound right? $4 was a 16% tip on 25? Yeah, I'd say that sounds about right, huh? All right. That was a part A, and then part B is really simple. It sounds like, oh man, I gotta do more. Nah, that was part A. Part B is really simple. They just said, what was the total cost of the meal including the tip? It almost seems like you want to make it more complicated. Like, it can't be that easy. It is as easy as you think. They're just saying, okay, you're going to pay $25 for the meal, plus you paid a $4 tip. So how much did you pay total? Well, $29? I know I say that as a question because I always think it's going to be tougher than that. That can't be it. No, you did all the hard work in part A, then part B is kind of the easy part, the nice part. All right, sounds good. So you notice these last three problems, I think they're going to be really similar to the earlier ones. It's just we have to kind of do the extra step of translating this long, kind of complicated problem into just one simple question, like this, what we wrote in green here. All right, I'm going to try to do that for this one. It kind of helps, though. I wouldn't, as you read it, try to write things down. Maybe read it, just make sure it makes sense, and then maybe reread it and try to write things down. So I'm just going to go ahead and read it. It says, to obtain her bachelor's degree in journalism, Addie must complete 125 credit hours of instruction. Okay, I guess that's like units, right? We talk about units here at our school. Same thing, credit hours. That's a lot of units, huh? 125. So if 20% of Addie's credit hours remain to be completed, how many credits does she still need to take? So it sounds like they're asking 20% of, okay, it's either 20% of what we want is 125, or 20% of 125 is what we want. But I think because 125 is the total, and she has 20% left, we're looking for what's 20% of 125? Because that's how many are left over. 20% of 125 is what? I guess that's what we're asking here. I think I phrased that kind of strange. You could have phrased it as, what is 20% of? So that's also an option. What is 20% of 125? Those, you'd actually get the same equation. If you think about the top one, 20%, remember you have to put that in decimal form. 0.20 of means multiply. So we're multiplying by 125 is equals what? The variable. If you set up the second one, what, that's x, is means equals 20%, I have to put that in decimal form. Of means multiply by 125. So you notice that these two equations are the same. It's just they have what's on the left side and the right side of the equal sign switched. But they mean the same thing, so don't worry. No matter how you phrase it, as long as you really understand the problem, phrasing it one way versus another way, it won't really affect the answer. I might as well solve the one on the bottom, I guess. It doesn't, actually, they're not really that bad, right? No matter which one you focus on, all you're really doing is multiplying 0.20 by 125. I always like the ones where I just multiply, not divide. I'm going to take 125, multiply it by 0.20. But this is another one where, you notice, 0.20, that's kind of complicated for no reason. I'm just going to write 0.2. Because what's 0.20 is the same as 0.2, it just looks more complicated. So I'm going to not look at this guy. All right, now I'm just going to imagine I'm multiplying 2 by 125. 2 times 5 is 10, carry the 1. 2 times 2 is 4, add 1, that's 5. 2 times 1 is 2. And now I just say, all right, there's only one digit beyond the decimal. So I'll put the decimal so that there's one digit beyond it. That must be x, 25. All right, does that sound right? They said, I guess that would mean that she has 25 credits left to take, and 25 credits is 20% of 125. I think that sounds about right. 20% is 1/5. I think it sounds right that 25 is 1/5 of 125. Okay. I believe that, but it's not too hard to convince me of things like that. Just kidding. Okay. So if you're getting bored, I'm sorry, but this is the last one in this section, and then we can move on to more fun. So this one's saying, okay, in the 2011 season, Drew Brees, I guess that's some football guy, I don't know. New Orleans Saints. Okay, yeah, that's football, right? I'm pretty sure that's football. Completed 468 passes. Wow, that seems like a lot. Huh. Completed too, not just through. Wow. Okay, sorry. Stay on topic. Just focus. This was 71.2% of his attempts. How many attempts did he make? Okay, interesting. But again, I think I want to rephrase this as a very simple question, like 71.2% of what is blur? Something like that. So the thing is, does it sound like we're taking, is 71.2% of 468 what we want? Or do you think 71.2% of what we want is 468? Well, I think because these are the completed passes. This is just a part of the total. The total is how many attempts. So I think we're taking 71.2% of the total, which is what we don't know, and getting 468, because that's just part of the number of total attempts that he made. So I think what we want to know is what is, or let's see, is that right? What is? No. Let me see. Sometimes it's kind of difficult to rephrase it how you want. I'm going to see here. What do we want to say? 71.2% of what? Because we don't know what we're taking of. The total is the part, which is 468. I think that sounds right. You think that sounds right? Yeah. Because 71.2% of the total attempts that he made was the number of completed passes, which is 468. All right, that makes sense to me. Now we're ready to translate it into an equation. So from left to right, the very first thing I see is this percent. But remember, you got to change it into a decimal. If I move that decimal point twice to the left, it's going to be directly in front of the 7. So it'll be 0.712. Of means multiply. What is the variable x? So of course, again, you can put a multiplication symbol between them, but I usually just write them next to each other. The word is means equals, and then 468 I'll just write. It's already a number, so it's perfect. All right, I think we're ready to solve. Ugh, now that I see what I have to do, I'm not excited. I have to divide by 0.712? Ugh. Doesn't sound like a good time. Okay, don't cry. It's just math, right? It's just math. X will be 0.712 divided into 468. Oh, Lord. That doesn't look that fun. I think I'm going to move the decimal again. Remember, when you divide, you're free to move the decimal as many times as you want to make it a whole number, as long as you do the same for the other number. I have to move the decimals 3 times to make both of them whole numbers. All right, so this will really become 712 into, it was 468, but now that I move the decimal 3 times to the right, it's going to add 3 zeros. Ugh, 468,000. I imagine I'm going to be doing a lot of guessing here, because I don't really know 712 times what makes something, I don't know. Anyway, so looking at this, the first number that 712 is actually smaller than is 4,680. 712 times what is 4,680, or close to it? I'm just going to kind of start guessing. I'm thinking of 712, imagine it's something simpler like 700. 700 times what is close to 4,000? Let's see, 700 times 2 is 1,400, that's not enough. 700 times 3 is 2,100, no. 7 times 4, too small. 7 times 5, too small. 7 times 6, that's close. 700 times 7, that would be too much, because 700 times 7 is 4,900. I'm going to see about 6. Maybe the number we have, 712 times 6 might be what we want. 6 times 2, okay, that's 12. 6 times 1 is 6, plus 1 is 7. 6 times 7 is 42. Yeah, I feel like that's as close as we're going to get. I think if I do 712 times 7, that'll be something too large. Maybe just try it, just to be safe, right? Oh, times 7. Let's try that. 7 times 2 is 14. 7 times 1 is 7, plus 1 is 8. 7 times 7 is 49. Yep, that's too big. Must be 6. Okay, 6 times 7, 12. Like we did the work over on the left side. It's 4,272. Let me subtract these guys. I'm going to have to borrow here. 10 minus 2 is 8. 6 minus 2 is 4. Gotcha. All right, let's try to bring down another 0. I'm just kind of praying this won't go on too long. So now I'm dividing 712 into 4080. I look over at what I already have. I've divided 712, or multiplied 712 by 6, and I got 4,272, which is a little bit too big. I'm going to try one less than that. How about 712 times 5? So let's see. 5 times 2 is 10. Carry the 1. 5 times 1 is 5, plus 1 is 6. 7 times 5 is 35. I think that's going to be as close as we're going to get. So I'm going to try 5 here. 5 times 712, 3,560. And then subtract these guys. Alright, I don't have to borrow yet. Oh, but now I do. Make this a 10. 10 subtract 5 is 5. Okay. Bring down another 0. I hope this eventually ends. I don't want to keep dividing forever. 712 into 520. Oh, that doesn't happen, right? That can't happen. Wait. Did I bring a 0 down? I forgot to bring the 0 down. Hello. I was thinking this 0, that's from these guys. Come on, pay attention. 712 into 5,000. Well, 5,200. I noticed I did 712 times 7. That's probably close. I think if I do 712 times 8, that's going to be too much, huh? That'll be too much. It's going to be 7. Okay, 712 times 7 was, it was 4,984. See, if I subtract those guys, I got to do a lot of borrowing. Borrow from you. Thank you, sir. Make you a 12, but you got to be borrowed from. Now you're an 11. Make you a 10, but you got to be borrowed from, so now you're a 9. Now this guy's a 10. 10 minus 4 is 6. 9 minus 8 is 1. What was this guy? 11 minus 9 is 2. This is now a 4 minus 4, nothing. Is this ever going to end? Alright, I've run out of zeros, so I have to put a decimal and add another 0. I don't know, is this Drew Brees guy really that good? Do I care this much? Just kidding. It's okay to say that, right? I don't really know football. Alright, bring down that 0. 712 into 2,000. All the ones I've tried so far over on the left side are way too big. Maybe I'll try, I don't know, what do you guys think? 3? Because I know 700 times 3 is 2,100, huh? We'll see. If I multiply, that's 6, and a 3, and a 21. I mean, I don't think I'm going to get closer than that. Am I right? Come on. Not going to happen. All right. So it must be a 3 that I want. 3 times 7, 12. There's 21, 36. If I subtract these guys, I'm going to have to do some borrowing. Make that a 5, which makes this a 10. 10 minus 6 is 4. 5 minus 3 is 2. And that's it, huh? Oh my gosh, another 0? Oh, it's going on forever. 240. 712 cannot go into 240, right? I'm no math major, but I'm pretty sure. So it's a 0. 0 times 712 is 0. 240's left over. Oh my goodness. Bring down another 0. Please tell me it goes in evenly. Okay. I don't think it does, huh? Oh, let's try another 3. 3 into 2,400. Or sorry, 3 times 20. 3. Wait, what am I doing? 712 into 2,400. I think 3 is the best we're going to get over here. 712 times 4 would be too big. I'm going to try 3 one more time. 3. That would be 21, 36. What if I subtract those guys? I have to do some borrowing. Oh my gosh. What did we get ourselves into here? 264. Okay, what's going to happen there? Let's see. 712. I'm going to bring down another 0. I think it's going to be another 3, huh? Alright, you know what? At this point, I have a feeling we're able to round this. Maybe I didn't pay attention to this problem. I think we should have rounded it. So I'm going to say it's 657.3. There it is. I'm sorry. I think I probably got this from the book, and it was supposed to have said, how many attempts did he make? Round your answer to the nearest tenth, or round your answer to the nearest whole number, whatever it is. Yeah, because if you're talking about sports, I'm no sports, fanatic, but I imagine if someone said, oh, did you know that Drew Brees made 657.3 attempts? You'd say, what the heck's the point of this 0.3? Just give me a whole number. 657, right? So, I don't know. Sorry, this took forever, but I promise though, on an exam or a quiz, you'd get a nice number. Or if it's ugly like this, they'll tell you, oh, round to the nearest 10th. So at least you know how far to go. But I hope that wasn't too painful. Try the homework, have fun with it. If you use a calculator, I guess I'm not going to know. So what are you going to do? I'll see you in the next video. Lots of fun. We'll talk about different things. If you're bored of percents, don't worry. It'll be something else. All right. I'll see you later. Thanks.